Hello, I am Josh Schilling, and this is my Lab 2 experiment for Physics 2212 at Georgia Tech. This experiment is a follow-up to Lab 1 experiment, which was charge tapes. The structure of this presentation will be first the experimental procedure followed in Lab 1 that yielded the results for this lab, followed by a conceptual introduction to Lab 2, a computational model, and then some conclusion and analysis. Quick overview of the procedure from Lab 1 was two tapes are given an electric charge, then brought near each other, and the force or the change in position of one of them was measured to then drive the amount of charge on each piece of tape. Conceptual introduction to Lab 2. In Lab 1, each piece of tape was modeled as one single point charge in the center of the tapes, whereas in Lab 2, this one, the tapes will be modeled as they are, which is a line of much smaller charges. So in this one, instead of modeling as one single charge, each piece of tape modeled as one single charge, it will be modeled as many small charges, many small sections, which are each experiencing a separate field that is being caused by the lower charge tape. The computational model for this lab was written in GlowScript. An image of this is on the left, the visual output of this model on the left. And so you can see the white arrow is the total electric force felt by the upper tape, exerted by the lower tape. On the bottom, the orange arrow is the gravitational force on the upper tape, and the small arrows are the individual instances of the field felt by that upper piece of tape. And so the upper piece of tape was split into very small sections. One section, for example, the leftmost section, is represented by those little dots on the far left side, and then the arrow coming up represents the field experienced by that small section that is exerted by the lower tape. The process for this model was to calculate the field exerted by a very small section of the lower tape acting on a small section of the upper tape. Then this was repeated, and then the fields were added together so that you had the total field on each small piece of the upper tape, and then all of those were added together so that then you could find the total field acting on the upper piece of tape, and then multiplied by the charges to find the total electric force exerted on the upper tape by the lower tape. Some measurements. A comparison would be that in this lab, it was calculated the charge on the upper tape, or on each of the tapes since they're equal, was larger than the charge calculated in Lab 1. And so in this one, it was 1.74 times 10 to the negative 8th compared to Lab 1's approximately 1 times 10 to the negative 9th. And so this was 62.5% larger than Lab 1's calculation. And that charge calculation came from the lower formula, which is an integration of the very small parts that the tape is broken into compared to the point charge approximation on the upper equation. All right. Some assumptions that were made in this calculation was that there's no air resistance since the tape isn't moving. For Lab 2, it was said that the tapes were very small individual charges instead of one center charge, which was the assumption made in Lab 1. And the assumption had to be made that the charge was evenly distributed because there wasn't enough information to build a model where the charge was not evenly distributed. So this helped with computation. It was also assumed that the charges between the two tapes were equal since they were produced using the same process, and it would have been difficult to find different charges. The estimated charge from the integrated distribution charge formula used in Lab 2 was greater than the previously calculated charge from the point formula, and the integrated charge formula result was most likely more accurate than the point charge formula because it took into account the length instead of making the initial assumption that it was all concentrated in one place.